move it here. Roger, it's not working. There
Make
we
it
go.
all
Thank
Roger.
you. Why AFM NG is such a game changer. We'll talk about the activation, what it means, how it is done. We'll talk about filtration and backwash performance of AFM NG, also in comparison to other filter media. And we'll talk about the new layering of AFM NG that we are introducing. And
you will be happy. It will become much easier.
Very simple. Very simple. We're simplifying things, which is important for me. Then I can remember them too.
Good.
Right? So anyway, and towards the end, as always, we have time to take your questions. For those questions, please use the chat function that you have available in Zoom. You can type in your questions there as we go through the presentation. I will pull them up at the end of the presentation. Okay. Then, as always, you can replay each session for a period of 7 days, and then it will be replaced with the next one. And on our website as well, you will find the PDF version of our presentation and the program for the remaining sessions to come. Okay? All right, let's get started. These are two things, or one thing, really, one topic we wanted to quickly talk about from our last session.
Yeah, I'm not sure anymore if that was in the American session or this was in the English session.
I think it was in the English session, yeah.
However, you know, there was some confusion. Okay, if it wasn't, are you sure about the English session?
Or was it the German?
Or, you know, if it was not in the American session, then let's not take it in. And
let's save not confuse, the time and move on. But
then let's not confuse it.
Yes. Okay, so learnings from the last session in 3 simple steps.
George Gammon.
Yes.
George Gammon.
Step number 1 was
Step number 1, no biofilm means no trichloramine. I make it black and white. It's not black and white, but much less of trichloramine.
Yes. What's not black and white is less organics means less formation of chloroform.
That's definitely not black and white. And number 3, we were talking about chlorates, which maybe is not in the US, you're not such aware, but you know, with sodium hypochlorite, you get quite high levels of sodium hypochlorite, especially if you use a lot of chlorine, much less if you have cal hypo and ACO to reduce chlorine demand helps here a lot.
Exactly. We'll talk about this actually in the next session in detail.
Absolutely. Yeah.
Okay. So I said we're going to take you to Scotland. This is where it all started as well.
Yeah, and this really, you see this gentleman here with the Scottish flag, you know, actually this started, I met Howard, this is our genius boy, Dr. Howard Dryden, and I met him in 2006, and that time he really looked out of Braveheart or of, you know, he had hair until here, you know, he looked really wild. But he is a very gentle person, and I mean, he is really the most knowledgeable guy in chemistry and in biology, and we admire him for this.
Yes.
And we're talking today again about AFM and what he has developed, and also the DAISY, but really about AFM. You know, ladies and gentlemen, he has not done it really for us in the pool industry. We are a byproduct. You know, he has done this for dolphins, because dolphins out in the ocean, you know, they can get up to 40 years. But in captivity, in dolphinariums, especially if the water treatment is not good and you have lousy air quality, dolphins die with 10, 15 years. And all of them are dying from lung diseases, and that's really caused by chloroform and by trichloramine. And this is why this was his mission to develop it. So he did this in the beginning of this century, and with the pools, he got to the pools mainly through me, I would say.
Yeah, definitely.
Okay.
So this is where it all started. Today, we have 2 state-of-the-art factories. I call them state-of-the-art. Dominic calls them the best of the best of the best.
The most sophisticated.
Yes.
Yeah, they are. They're really
they
outstanding.
Are. We can produce a total of 50,000 tons of filter media, of AFM per year combined. And we are active in 3 industries. As I mentioned, it all started in the aquarium and aquaculture industry, which is maybe 10% of our business today. Then we added the swimming pool industry, where you started 12, 15 years ago, maybe,
15 years
selling
ago,
the first AFM here in Europe, which is probably about 50% of our business today.
Yeah, it's still probably 50, or it was last year 50%, 40% water treatment, but water treatment is now catching up heavily. And I would be surprised, you know, if water treatment would not take the lead until end of the year or beginning of next year.
Most likely. Okay, so another or an important aspect of AFM is the sustainable circular economy. What does that mean, really? You know, I mean, you can show a lot of nice pictures and we will explain some of these steps, but really we take garbage, a garbage product that usually ends up in the landfill in many countries, and we make a high-end product. We take garbage and we make green gold out of it, literally. How do we do this? So the first step is we take recycled bottle glass from sourced locally from the areas where our factories are in Scotland and Switzerland. So we have 100% recycled glass that we're using. We're putting it through a production process that is 100% self-sufficient when it comes to water use. We only use rainwater for the wash cycle. And we also generate all the power, the electric power that we use on our roofs. We can generate a maximum of about 850 kilowatt hours of power on our rooms, 850,000 kilowatt hours. Very important for us, right? Then also the zero waste
by the way, you also forgot to mention, and we store them in Tesla batteries manufactured in the United States.
Absolutely.
We're Tesla fans.
Yep. Zero waste means all waste that comes out of the production process is either being recycled or it's either being used in other industries, and sludge is disposed of responsibly. Actually goes into a biogas plant now.
Again, to produce new energy.
Yes. And last but not least, you know, in some areas we do have a take back for AFM. We can put it back into our production process, you know, if it's close by to our factories.
But you send it back from America, that would be not sustainable.
No.
Very cost effective and would be not sustainable. What you can do, you know, we've used AFM, you know, use it as sand, right? You know, if you have the trenches, you know, if you put in the lines, you have to fill this with sand, perfect for old AFM or sand, or if you have to level some plates, you know, you can mix it in the soil, makes your garden better. So it's not contaminated, it's backwashed and it's perfectly to use.
Okay, let us take you through the main steps of the production process. Step number one is that from the recycled glass, we remove all metals, papers, and plastic. And you see this in the video here.
You have to go back and one forward.
Okay, go back one and one.
I'm very technical, as you can see.
One forward. Then it will play again. You can see how the glass is being fed into a hopper. It then goes through a strong magnet to remove all iron metals, magnetic metals. Then it goes through an air separation.
And then the main washing that we use, the rainwater that you will see it later. And then we spray really with very high power on it. This is the sludge, you know, from all this waste. And this goes then to biogas, and not the contaminated, the dirty water is then going through decantation, AFM filtration, and back into the washing. So we just have to top up the backwash water, which is roughly 10 cubic meters per day.
Exactly. So this is the wash cycle that we mentioned.
And just this washing plant, you know, you're talking about an investment of about $3 million. So it's significant.
It is.
We spend a lot of efforts, you know, to get this very clean. I mean, to give you an example, you know, the raw material comes in with 50,000 grams of organics per ton. And in the washing, we bring it down to 5,000 grams. And then in the main process that Philip will explain us in a minute, you know, with the dryers, with the color sorters, with always air separators, we bring it finally down to 5 grams. So from 50,000 grams down to 5,000. This is a factor, Philip, not of 1,000, of 10,000.
10,000. Absolutely.
Even more exciting.
Absolutely.
Yeah.
Okay. Yeah. So the cullet now goes into a dryer and gets into the factory building.
The dryer is to dry the glass because then you can color sort it better. But it's also a sterilization because we heat it up to roughly 80 degrees, you know, before it goes to the color sorter. And yeah, that kills bacteria, viruses.
Exactly right. Sean, you've seen the production here in Switzerland when you were here. What happens next now?
After the drying, with the color sorting, of course.
The color sorting, exactly right. Huh? So this is what you see here. We have 3 color sorters that remove all
that you
white
see
glass.
here now in the video. It's an amazing machine. Look like the white color is rejected. It's amazing machines. They are coming from Germany. For me, it's always a miracle to see them.
Yeah, and it's incredible. It's incredible to watch.
Yeah,
it's really neat.
You know, in one pass, you color sort 90%, and we make 2 passes, so you get it down to 98% of purity.
Yep, and we'll tell you in a second why we can only use green and brown glass. Huh? It then goes into a crushing loop where the cullet is broken down to the grades that we want, the exact size and shape, and goes then through a huge sieve. Huh?
Yeah,
a sorter.
The beast and the beauty. The beauty and the beast. Reminds me also in the video.
Yeah.
The beauty and the beast. And because if in the crushing process, you can't tell, make only small ones, you know, it's a kind of, how do you call this crusher? It's a vertical impact crusher, you know, that you crush glass on glass, that you don't get any sharp particles and edges.
Yeah, exactly.
But that will mean you always make big and very small grain sizes. This is why you have to sieve it. In the beast, you make the big ones, and in the beauty, you make the grade 0 and the grade 1.
Yes. So after crushing and sorting, the AFM grade 1 and 2 will then go through the activation process.
And this is exactly what you see here.
Yes.
Here we spray chemical number 1, chemical number 2, and then it goes again in a heater, you know, where we heat up and you see how it's dancing, like Dance with Wolves, right? Where this is the reaction in the last heater, in the activation heater, where we make out of best glass and AFM.
Yeah, that's it. From there, it goes into the bagging plant, quality control, and then it goes out to you. Okay.
Yep.
That was short overview. So now let's talk about AFM, and you know we do have 2 types of AFM. We have our AFM standard and our AFM NG that we have that we're in the process of introducing in the US as we speak. These 2 products have 2 things in common, very important. The first one they have in common is the self-sterilizing surface. This is important because AFM, as you know, is resistant against bacterial growth. Biofilm cannot form on the surface of the grains, and this is because it has a self-sterilizing surface. So both products have this in common. Another thing that both products have in common is the increased surface area. As Dominic just mentioned, we put AFM through an activation process, and this chemical and thermal treatment increases the surface of the glass by a factor of up to 300 times.
And this is the kind of surface that you get, you know, if these mountains here, it's a mesoporous surface, so but it's not inside surface, it's really outside the surface. Instead of smooth as glass is in the beginning, you get to this. And this brings you to adsorption capacity. And above here, you see adsorption and absorption. So adsorption with a D like Dominic, and absorption with a B like Beatrice, or what's the common name, Bernd or?
Brigitte Bardot.
Brigitte Bardot, exactly. Yeah, double B.
In honor of Florent, our French marketing manager.
Yeah, we were all in love with her. Yeah. I was a baby at that time. Adsorption means you attract particles And absorption means you take the particles in, it's like a swarm, right?
Yeah.
And
Sponge, like a
like a
sponge.
sponge, and you know, there you don't get them back, so that will start to biofilm. Where with an absorption media with a proper backwash, all is gone and it's clean again, ready to go.
Yep, exactly. Excellent. So what's really the difference between the two products, huh?
Me or you?
I'm doing it, but
Good.
I need to sneeze, I think. Sorry. Okay, so what's the difference? The difference is the surface charge of AFM standard versus AFM-NG. The AFM standard has a negative surface charge. It's very efficient in attracting positively charged particles like flocks, for example, also a number of metals like iron, manganese, arsenic, because they are positively charged. There's an electrostatic attraction that is taking place with AFM standard. AFM-NG, on the other side, actually has a neutral surface charge, and its surface is hydrophobic. And I'll talk about this in a second. This makes AFM-NG extremely good at adsorbing organic substances like fats, lipids, oils that are also hydrophobic. So this, in comparison to AFM standard, gives AFM-NG about 30% higher adsorption of organics.
Exactly. So, I mean, to summarize, you know, we will continue with AFM standard. AFM standard is great. And it's the very best for heavy metal removals that we use in many countries, mainly in drinking water, groundwater treatment, as you mentioned, arsenic, manganese, and iron.
Yeah.
But for pools, NG is another level. It's just another level, especially if you do not use coagulation flocculation. With coagulation flocculation, honestly, the difference between standard and NG is not that great. It's more or less equal, but without flocculation, NG is better. And especially if you have very soft water, the difference is huge.
Yeah.
So it has to do something with the hardness of the water. We will not go too much in detail.
Yeah.
In the future, we bring now the NG. That's the job of Sean, as quickly as possible to the US. And this is the very best that you should use in pools.
Absolutely.
Anything to add here, Sean?
No, you know, we've got AFM NG here in the States now. I have grade 1 in NG here, ready to go. We have a number of customers that have ordered containers of AFM NG, and we've got those on the way. Some of them are landing this week, I believe. So it's here, it's ready to go.
Okay, don't forget also to go now with the grade 2 in NG. Okay,
Absolutely.
Let's go on.
Okay, so we do have a 2-minute production video that you can find on our YouTube channel. I highly recommend you use it, watch it, send links to your customers, put it on your website. It's a great way to understand how AFM is made. We're not going to show it now because you've seen it at the introduction. Okay, we were talking about the importance of the self-sterilizing surface of both AFM standard and AFM NG, because that makes it bioresistant. Sean.
Yes.
You remember the 3 problems that we discussed last time with biofilm. You want to take us through this?
Sure. As we discussed in session 4, when you accumulate biofilm in the filter, this leads to inconsistent and unreliable filtration due to clogging or clumping of the media, and that leads to channeling. We can't backwash these clumps of biofilm out, so this accumulates over time and causes more and more problems as we go along long term.
Right.
Second, and really kind of a scary thing to think about is the fact that this biofilm protects these nasty pathogens that we don't want in the water, like Crypto and Legionella, protects them from the chlorine that we're putting in the water. So it is a home for growing these materials that we're trying to eliminate with disinfectants. And finally, biofilm, as we learned in session 4, creates an acidic environment, which is needed for the production of trichloramines in the water. So when we eliminate biofilm, we eliminate the #1 source of trichloramine production in swimming pools. How does it work? It works well. The activation process, we take green and brown glass, and green and brown glass contains metal oxides that we activate with our process. Green and brown glass in itself is sort of resistant to bacterial growth. Our activation process amplifies that with the mesoporous surface, with the increased surface area. When water molecules and dissolved oxygen come in contact with the surface, there is a catalytic reaction that happens, and we form free radicals on the surface of AFM. Very, very powerful disinfectants. And that eliminates biofilm, it eliminates bacteria from being able to stick to the media, and it eliminates the growth of biofilm.
Yep. So, no biofilm. I think you nailed it, huh?
Absolutely. Yep. Even I have nothing to say.
Yeah. Perfect.
By the way, I like the new photo behind you with the NG. On one side, the drop, on the other side, the NG. Yeah. Okay.
And in the middle, I'm
learning.
And in the middle, we have a hydrophobic surface in the middle as well.
Hydrophobic head. Okay.
So this is one of my favorite slides, and it's been around for a very long time. And this is really one that opened my eyes with AFM. So the top two images that we have, on the left-hand side is new sand. On the right-hand side is sand after 3 days in a drinking water filter. And what you're seeing here is 100% bacterial colonization. This isn't something that you would see with the naked eye very easily at this point, but it is evidence that we've got bacterial colonization occurring on the surface of sand. On the bottom, we have new AFM, as you can see on the left, and then used AFM after 5 years of treating sewer water. There's no biofilm growth on the AFM. These samples were taken after backwash as well. So I'm sure there was a lot of nasty stuff that had adsorbed itself on the surface of that AFM, but after the backwash, it remains completely clean. And for example, a bacterial count in a 5 grams of filter media, yep, at a water temperature of 37 degrees, which I believe is 98.6. In AFM, we have 18. This is from this sample, a bacterial count of 18 versus 3.6 million in the sand. So it does work. It's not snake oil. This is really an incredible thing that Dr. Dryden has achieved.
Yeah, let me just add, how you do it. You run on one system, run same filter, one with AFM, one with sand, for a couple of months, you backwash them. And then after a backwash, you take 5 grams of filter media, 1 time sand, 1 time AFM, and then you put this in deionized water, so there is no bacteria in it. You shake it, and then you breathe at 37 degrees, this on a petri dish, and then you can count the colonies. Not that important, but you see it's more than 1,000 times more bioresistance. Actually, it's even more, but I'm not so good in calculating.
Very well said, Dr. Graf.
Good.
Yep.
Go on.
Okay. Summary, Sean, huh?
Sure. So what are the consumer benefits of using AFM in a pool filter? First, of course, no bacterial growth, which means no channeling. That's going to be a safe barrier against pathogens. So we're going to have clearer and safer water. We're not going to convert urea to ammonia, as we learned in the previous session. So we're going to produce 50 to 80% less trichloramines. That means also no chlorine smell, no corrosion of indoor pools. Obviously, the fewer harmful disinfectant byproducts we can produce, the better. And then, of course, which probably is the most noticeable thing on a residential pool, is no loss of your filter efficiency. Over the years, because there's no biofilm, because there's no channeling, you're going to have stable and reliable performance. And it's going to outlast all other filter media by many, many times.
Sean, you said that before 2 or 3 times, but it's good that you did. And we do, because, ladies and gentlemen, we are brainwashing now a little bit. You don't get it in the first time, so we will tell this another 3 or 4 times.
Yeah,
but now we come to something really new and absolutely exciting. And I guess
That's the game changer,
this is the
AFM-NG.
chief who will take over here.
Okay, I mentioned that we mentioned that AFM-NG is hydrophobic. So let me quickly explain this. Substances can be grouped either as hydrophilic or as hydrophobic. A hydrophilic substance has polar molecules. Basically, it means it has an electrical charge. And hydrophilic substances, they love water. And they also love other hydrophilic substances. So an example, the best example for a hydrophilic substance is actually water. Water loves itself, literally. But also like salts and sugar. That's why salt and sugar dissolve very well in water. They really like each other. On the other side, we have hydrophobic substances, which means they reject, they repel water. They don't like to be in water. These are substances that are non-polar. They usually have no charge. And they like each other. An example here is oil, for example. If you add oil to water, it will not mix. It does not like to mix with water.
It goes to the surface.
It goes to the surface, exactly. So why exactly did we make the surface of AFM-NG hydrophobic?
Let's bring this in the next one.
Yes.
But maybe here to show,
Okay,
you know, hydrophobic and hydrophilic. Hydrophilic is what we have here up. This is AFM standard. It loves water. And hydrophobic is what you have here. That's in the NG. It doesn't love water, as you see. If you can test this also, you know, for your AFM-NG that you will get. It will be not as hydrophobic as this. Here we really overcooked it. And you will get a slightly less concentrated version because otherwise we get some problems in commissioning. So you get really the sweet spot. But it's very obvious, you know, to see the differences. It also gives us, you know, in a way, an advantage because before, you know, people said, well, this activation, this is marketing story. How can you show it? How can you prove it? We could, but it was difficult with lab, etc. Here, very easy, just a drop of water and you see the activation.
Yeah, yeah. Great way to demonstrate in front of your customer as well.
So,
okay, so hydrophobic substances love each other.
Yeah. And this is, as you said, you know, or let's go, I leave it to you, but maybe quickly to the first point, microplastics.
Yep.
You know, Howard, he has developed AFM-NG because he wanted to filter microplastics. Microplastics are hydrophobic. Now, AFM standard can filter microplastic, but only with coagulation flocculation. For example, our APF and a lot of these applications, you cannot use it. So we wanted to develop a media that can filter microplastic. And this is why he has done AFM-NG. This is hydrophobic and the microplastics are hydrophobic. Maybe one comment, why microplastic? Why this is a problem? Why don't we want to have this in the water and definitely not in the oceans? Because on microplastic, it's a coagulation point, it's a concentration point on toxic chemicals. And where you concentrate them on a high degree, then they end up in the ocean. On the ocean, they are absorbed from plankton, and that kills the plankton. And the plankton is the lungs of our planet. And if we lose the plankton, we get in a serious problem. And then while testing it, we have found that, which is not surprising, this not only works for microplastic, this works for, I leave that to you.
Yeah, it works for most organic matters that we find in a pool. So proteins, oils, lipids, they are all hydrophobic, which means they are immediately attracted to the surface of AFM-NG.
So
the more we can filter out, we've learned this in the sessions before, the less organics we have in the pool, the less potential for harmful chloroforms and other THMs.
And they are not good, as we learned last session.
Yep.
They're not good. They're nasty.
And by the way, you get much clearer, nicer water too, huh?
Yeah.
So, yep.
This is why we call it a game changer.
Yep.
And here again, very sophisticated.
Very sophisticated
here you
video.
See a plastic. It's not a microplastic. It's a macroplastic. And you see now we are in the NG. Look at the adsorption. Here, AFM standard.
Nothing.
No adsorption. because it's hydrophilic, and here in the AFM-NG, hydrophobic, it absorbs.
Yep. Also a great way to demonstrate, huh?
Sure. Yeah.
Okay. Yeah, I love this video because it was so cheap. Really. Okay, filtration performance of AFM-NG. This is your favorite part, huh?
Yeah, maybe you know our IFTS report, you know, and the IFTS report, there was a comment in the last session, not from the America. You say, well, you made this graph. Can you prove it? Yes, we can. This is out of these 20 papers that we got from this IFTS report. This is also why each of these tasks cost $6,000. Where you see, can I quickly have the command? Where you see the different conditions, flow rate, 20 meters per hour, 1 meter of filter bed. But the important thing is filtration efficiency. You have upstream 12,700 particles, which are 1 micron, feed it into the filter, and 685 past the filter. The rest is trapped, and this is 94.6. Philip is general enough of me to round this to 95. This is why our famous 95% level limit goes down to 1 micron. You know, with AFM standard, we were here. We were here at 4 micron. 4 micron, of course, we also filtered, but we filtered 99.3. So really, we improved from 4 to 1, and this is great. This is big. And this is the graph that I told, and this is done from us, but based on these results, and AFM-NG, 1 micron sand. Here we use the Lisen butter sand. That's the best one that you get in the UK, in a size 0.5 to 1 millimeter, 20 micron, and then some glass sand, which the very best was 25, and then you see all the others are going up. I'm still in the lead?
Yeah, these are the results for sand.
This is the result from sand, again from IFTS. You see 5 micron removal rate, 73%, and only a 20 micron removal rate, 95.
Yep.
Okay.
So Sean asked me to add this slide for our US friends, because really, you know, you've noticed we're telling you get a 1 micron filtration at 8 gallons per minute and square foot filtration velocity. But we know that in the pool industry, you're not filtering at 8 usually. You're filtering higher. So why did we test at 8? Because really, we kind of took a middle ground. Very often in the water treatment industry, we're filtering at 8 or lower. In the pool industry, it's a little bit higher. So Sean, tell us what we see here.
Sure. So this is the filtration performance of AFM-NG in the light green, AFM standard in the dark green, and silica sand as yellow. And some things to know, you know, we're looking at 8 gallons per minute, 6 gallons per minute. At 12 gallons per minute, the bar chart on the far right, you can see our 95% removal of 5 micron particles at 12 gallons per minute. AFM standard at 12 gallons per minute achieved a little over 80%. And sand at 12 gallons per minute per square foot can only achieve about 30%, which is really almost nothing when you consider, again, that we only filter around 60% of the water every time we turn the pool over. So it's very ineffective at anything below 20, 30 microns. So this is just, I really wanted to show this so that our American customers would understand that, look, even if you run this at a commonly used rate in the US, we're still going to achieve far, far superior performance to sand, as well as all the other benefits that we've always talked about: backwash performance and reduction of chemicals, reduction of backwash water efficiency, all these things. So this is a very important chart, you know, to put it in context for the US.
Okay, maybe let me add one thing. I fully agree. You know, then we are on 18. I have to change the gallons per minute, 18 or 20 gallons per minute, or we think we are. The moment where you add the flow is, very often you will be surprised how low your filtration velocity and backwash velocity will be. So again, here flow is something good to double check. But really the message is the lower the better, and our recommendation would be really the 12. That would be ideal. Maybe nighttime even less, but that would be great. Right.
And one other little note, we know that because of past sessions, crypto is 4 to 5 microns in size. In one of the prominent filtration experts in the U.S. has shared publicly and told us as well that he considers 90% removal of 4 and 5 micron size particles effective as a crypto barrier. So that's something to keep in mind. If we're able to filter 90% or better 4 and 5 micron size particles, then you're an effective crypto barrier.
Yeah. That was Dr. Ambergy, huh?
Yes.
Yeah, exactly. Okay, great. So here's one last example. This is of a crushed glass media that we see here in the European market. Again, at the 8 gallon per minute, so 100% comparable to AFM NG. You see, this, by the way, is independent tests that the manufacturer published. We didn't do this. We have this from their website.
Saved us $6,000.
Saved us a lot of money. Again, so you can see a 5 micron filtration rate here at 60% removal rate of 5 micron. And you have to go up to 30 microns to reach, you know, a removal level of 95%. Huge differences.
Yep.
Yeah. Okay, backwash performance. We talked about the importance of filtration performance.
So we are again in the brainwashing mode.
Yes, but backwash is important too. And you remember this from our sessions before. We recommend the backwash velocity of a minimum of 16 gallon per minute per square foot. This will give you a bed expansion of 15%. If you can get a little bit more, it's better. It helps remove the particles that are captured in the bed. You can see this in the video here, how the bed is expanding. And while it is expanding during backwash, you can see how it releases the dirt particles. Compared to sand, you will then experience significant backwash water savings, because in order to expand sand by 15 to 20%, you need to have a backwash velocity of 20 to 24 gallon. Sand is often biofiled, so you need to backwash it longer too. This leads to an average backwash water saving of 50%.
Same story here. Backwash efficiency, it's after 4 minutes, you're done. And it's just much easier because of this adsorption to backwash it. Go one more and then you see how this disappears.
Yes, exactly.
This is how we backwash.
Very simple. Shear forces will remove everything from the surface. Okay, we do have a 2-minute video that summarizes everything we said in half an hour.
Yeah.
Right?
So we did a lousy job.
Yes.
Let's look at the good job.
Let's look at this here.
Have you ever wondered how bacteria survive in a swimming pool, and why the sand you're using in your sand filter needs to be replaced every 3 to 5 years? The main problem with sand, crushed glass, and other filtration media is biofilm, a slimy, acidic substance formed by bacteria in your filter that protects them from oxidants, inside which bacteria can grow and multiply quickly. After only 6 to 12 months, biofilm starts forming clumps, leading to the formation of channels in the filter bed. With time, filtration performance becomes inconsistent and unreliable by allowing unfiltered water and bacteria to enter the pool while increasing operating costs and water turbidity. Unfortunately, biofilm also creates serious health hazards, as bacteria in the biofilm generate ammonia, which reacts with chlorine to form harmful disinfection byproducts. These byproducts are responsible for the unpleasant chlorine smell, causing eye, skin, and lung irritation. They are not good for you, and especially not for the children. But is it possible to get safer, clearer water and healthier air conditions with the same sand filter you've been using for years? It's more than possible with AFM Activated Filter Media by Dryden Aqua. AFM is a self-sterilizing and fully bioresistant filter media made from recycled green and brown glass that replaces sand in any type of sand filter. AFM gets its self-sterilizing properties from free radicals formed on the surface of the grains when water flows through the filter. This renders the formation of biofilm impossible, making AFM the only 100% bioresistant filter media on the market. What's more, our patented activation process modifies the charge of the glass and strongly increases its surface area to give AFM unique filtration properties. With a certified 1-micron filtration, AFM surpasses the performance of sand and other glass filter media to provide exceptional water clarity and lower chemical consumption. The activation of the glass also enables AFM to reduce the formation of harmful THMs by up to 50%, while providing substantial backwash water savings for a quick return on investment. Extensively tested and certified, AFM outlasts all other filter media and is the only glass filter media certified for pools and drinking water applications. Enjoy clean and healthy water for years to come with AFM activated filter media.
Okay.
Why did we make it so complicated? It's
Why?
all in here. 2 minutes. The best instrument to explain and to sell it.
Yes, you find this on our YouTube channel. It's a great way to show your customers. It's a great way to attach the link to your email signature or to put it on your website. It's a great tool. Okay, next, let's talk about the layering, huh?
Yeah.
So, up until now, or a little bit back into 2019, this was our typical grading. For grade 1, it was 0.4 to 1. For grade 2, 1 to 2 millimeters. And this was our recommendation. You know, I apologize. This should be, what is 800 millimeters? About 30 inches.
Mm-hmm.
Huh, Sean, roughly?
Yep.
Yeah.
Yes,
Okay.
sir.
So we were advertising a 70-30 layering mix. That was our standard. Now, as of now, and with the introduction of AFM NG grade 2, we recommend and we simplify it to a 50-50 layering. Why are we doing this and how are we doing this? These are two reasons. One is you can see that the size of grade 2 has slightly shifted. It's now 0.7 to 2 millimeters instead of 1 to 2 millimeters. What does that mean? This means that AFM grade 2 is now effectively becoming also a filtration layer as opposed to only being a support layer.
So the smaller grains give you a better bed expansion. So we improved in the bed expansion. And with the NG activation of the grade 2, it becomes really a filter layer, hybrid. Go one back and forward. No, yeah, back. That's the other one. And one off. I'm really proud, you know, what float. No. Sorry.
Okay, yeah, I got it.
Have a look now on the filter on the left side. What happens? Bam, it changed to 50-50. And here that it moves to 50, 25, 25. This is how we want it in the future.
Very simple, 50-50. Now, Sean has a great calculation tool also that he's made ready for this.
So why do we change?
Why did we change? So the first thing I want to mention here is, you know, we said AFM grade 2 is now also a filtration layer. And you can see this. The yellow line here is 100% AFM grade 2. The filtration performance of 5 microns is 90%, as opposed to sand that you've seen in the slides before, which is 73%. So AFM grade 2 performs better than sand grade 1.
With a much bigger grain size, you know, which is,
yes,
and it's a big difference.
That's the hydrophobicity, huh?
Yeah.
And now you can see here the two lines at the top. This is the 70-30 layering and the 50-50, and there's virtually no difference.
It's one line.
Yeah. So in order to simplify, we said, let's go with the 50-50 layering. This will make everybody's life easier.
Yeah, if you have 4 bags, 70%, 30%, it's kind of complicated. 50-50 is 2 and 2.
Exactly.
What do you do if you have 5? You make 3 and 2 or 2 and 3.
I would do that too.
Yeah.
I would do that too. Okay. So it's basically a hybrid grade 2, right? Because it's a filter layer and a support layer.
Yeah.
But there are two other important advantages
Yeah,
of
and
this
this
change.
really came also a little bit from the experience in Switzerland. To be honest, we forgot in Switzerland or in Europe to change it to the 50-50 layering. And we have done a great job, you know, in improving the bed expansion, but we have done it nearly too good. So if you stay in a 70-30 layer, which would be the green area, and you backwash it at 40 meters per hour, you have
which is 16 gallons per minute.
Mm-hmm.
Okay, yeah, sorry.
Yeah,
yeah,
no, it's okay.
Then you already have 40% of bed expansion. In a 50-50, you have a 25. And this is ideal because 40 is might be already your free board. And if you drop the water temperature then to 10 degrees lower, I'm not good in Fahrenheit, I apologize for this, then you have 50 and then you lose media. Not a problem for me, not for Philip, not for Sean, but yeah, in a way people do not like it. They want to stay in the filter height they bought.
Sure.
So it gives you the ideal bed expansion, not the highest, the ideal bed expansion.
Yes.
We will play with this, you know, if we only can backwash at a relatively low, maybe you take it over with the gallons because you're much better. You know, if you, let's say on a very low levels, 30 meters per hour, that would be what?
12 gallons per minute square foot.
We still can work with AFM, but there probably you would use then 70% grade 1 and only 30% grade 2,
yes.
which you still get to the 25% of bed expansion.
Mm-hmm. The second advantage you get of the 50-50 is the pressure drop through the filter bed goes down. You know, we're looking at filtration velocity here of 12 gallons per minute per square foot. This is the 70-30 versus the 50-50. You're losing 0.1 bar. That is about 1.5 PSI, which, you know, is that a lot?
It can be a lot, you know, especially in public pools where you have big pumps, you know, it can make a difference of 1, even 2 kilowatt.
Mm-hmm.
It depends a little bit on the curve, you know, but if a flat curve, that can make quite a difference.
Yeah.
So another advantage. So to summarize, same. Do we have a summary?
Yes.
Okay, we do.
So a 50-50 layering leads to outstanding filtration efficiency.
As good as 70-30.
Exactly. We have an ideal bed expansion without the risk of losing media and less pressure drop.
And there is also video explaining this. If you forget this, this is not for end consumer. This is really for you, but it's easy, 50-50. Just trust us. That's what our wives are not doing.
Yeah.
Okay, let's summarize, you know.
Probably know why.
Or is Sean?
Okay.
No,
yes,
this is Sean doing. Sorry.
Sean, you summarize this, please, for us.
Sure. The promise of AFM in private pools, or what we call residential pools also in the US. Obviously, with better filtration performance, we're going to have much cleaner and clearer water within 24 hours of installing AFM. We're not going to have a chlorine smell. So, you know, indoor pools, even outdoor pools, we get a chlorine smell sometimes because of the amount of chlorine we use in the US. And we're going to greatly reduce skin and eye irritations and most likely eliminate them, especially with AFM NG. We're going to reduce chemical consumption and maintenance by about 50%. Depends on the size of the filter and the quantity of filter media, but there's a number of reasons behind this. We're filtering out organics as one. We're also removing a lot less water from the pool because we're going to use 50% less backwash water. So we're dumping, you know, with less fresh water, we are going to consume fewer chemicals because we don't need to treat the fresh water and turn it into pool water, for example.
Yep.
And this is a absolute must with chlorine-free treatments as well.
Right. So
which we have a question about that in the chat that we can answer at the end as well.
That's right. Okay, so Dominic, you mentioned your wife before.
No, usually we make always a case study, and let me do, instead of a case study, let me introduce you the Estee Lauder factor. Sean, you know the Estee Lauder factor?
Oh yes.
Okay, that's a new one. You will love it. This nice lady here, this is my ex-girlfriend, which I met 32 years ago. We're still in contact and married for 22 years. And that gives you an indication she's not anymore 20, but she looks, yeah, it's a 5 before, but I think she looks like 30. And that may have different reasons, you know, why this is the case. Is it me? Is it, I don't know. Or is it one of her beauty treatment called Estee Lauder that she uses? So what has this to do with AFM? I was 5 years ago, I was with our Spanish partner, and we were talking about AFM. He said, it's a great product, it's fantastic, I would like to sell more, but you know, Dominic, it's really expensive. It's really expensive. Yeah, it's 2 or 3 times more than sand. And I said, well, Patrick, you know, it's 50 bucks a bag, you know, 50 pounds bag. Mm-hmm. So it's not such a huge difference. They said, well, 50 bucks, you know, per bag, that's maybe not a lot of money for you in Switzerland. You are Swiss, they are all rich, which is not true, by the way. But in Spain, it's a lot of money. So what can you say? Never argue against a customer, especially not if it's a friend. But on the way back to the airport, my wife called me and said, honey, can you bring me 2 of these Estee Lauder things? So I went in Spain to the airport in the duty free and I bought 2 of these bottles. This here, the 200, that's the price of 1 of these bottles. 1. I was shocked by this. What I learned, I have a really expensive wife. But that brought me to the idea, let's compare it, you know, with AFM. And actually, you know, if you fill a tier 60, you know, the price difference between sand and AFM is less than 200. And this brings you in a factor. And this is the Estee Lauder factor 0.9. And you see, you have to go up to tier 140, where you get more than 2 Estee Lauder factor. Mm-hmm. So what do we learn by this? As already Nietzsche, a German philosopher, said, everything is perspective. Everything is relative, I think. This is what he wanted to say. Yeah. So I like a little bit this story.
Put this in, absolutely, have to put this in relation. Yeah. So we were talking about the promise for private pools. There is also an important promise for public pools, right, John?
Sure. Very similar to private pools. We're going to, again, eliminate the chlorine smell, very low trichloramine levels. We're going to lower inorganic chloramines as well, 3 to 5 times lower using AFM compared to sand. Very important, obviously, for indoor pools as well as outdoor pools. Indoor pools, we're looking at the health of the swimmers and the people, the lifeguards, the staff in the building, as well as the building itself. If we remember that trichloramine is very volatile and very corrosive. Number 2, we're going to lower THMs like chloroform by 50%. We're removing 50% more organics, so we're producing 50% fewer trihalomethanes. And then a big one, and this is something that's quantifiable after they start using it, is substantial backwash water savings. The return on investment is within 2 years on indoor pools, within 3 years on outdoor pools. We see it all the time. We have the Venetian and Palazzo hotels in Las Vegas switched completely to AFM, and they're saving millions of gallons of water a year in backwash water now. It's a huge savings. Philip, you might want to speak to the note on the right-hand side here.
Which, by the way, you mentioned these 2 casino resorts in Las Vegas. They confirmed this in writing. I forgot how many millions of gallons of water they are saving. They converted 28 swimming pools from sand over to AFM a number of years ago, and their payback was 6 months.
Yeah, it was very, very quick.
Huge. Okay. Yes. Should I mention the right side?
Yeah,
the red side?
You want, if it's important for the US. I don't know.
Sure.
Yeah. Okay. So when we say, you know, when we measure total combined chlorine, there's an inorganic and an organic component. We are removing a lot of the inorganic. The organic, the organo. chloramines,
we are
they're
more
staying in the
avoiding
water.
it. It stays organo.
Yeah.
I mean, to make it short, if you have a nice dimension system, you know, indoor pool, you will get 0.3, 0.4 combined chlorine, which is great, and with perfect water conditions, with perfect air quality conditions. But in some countries, such as Germany, Switzerland, we have to be below 0.2. And in these cases, just in indoor pools, never a problem in outdoor pools. There we have the sun as a big UV system. We have to add a layer of activated carbon to remove this below 0.2. So the only that we cannot promise is that you will have much less of total combined chlorine. Very often you have, but it can be more or less equal. But we are talking about this a lot more in session number 8.
Yep.
I take this, or you?
Yeah, here's a really great case study that we have from Sweden. We both like Sweden for a number of reasons.
Yeah, more and more.
More and more lately, especially. But this is a great swim park here with a number of pools that was converted over to AFM.
Yeah, 24 tons. So
24 tons. Yeah.
Good.
Yeah.
And you know the savings, and it's old. It's 6, 7, 8 years old. You know, huge savings in chemicals, acid. By 2/3. I don't know how they achieved this. Chlorine reduced by 30%. This is very logic, but really the savings came from the water consumption. You know, they saved. I don't know what is this in gallon, 8 cubic meters. It's a lot of water. It's a lot of water that you have to buy, to heat, to whatever. At that stage, you know, we promised these
2,000 gallon.
2,000 gallon. Okay, we promised this investor return on investment of 5 years, and he came back then after 1 year and said, "Dominic, you were wrong." Okay, it was not 5 years; it was 2 years. So I apologize for this. But really what I loved in this is his statement, you know, where he said, well, smell of chlorine is gone. Customer asked if we are still using chlorine, or we can't smell it. And this is why we moved now our coffee shop just beside the pool. And this was definitely not possible before because of atmospheric condition. And by this pool, we sold some big projects, you know, like in Poland, one with 100 tons, etc. So it's a really good one. It's a nice case study.
Great example. Okay. We are coming to the end. We would be happy to answer any questions that you have.
Give us, no, stop. Give quickly the outlook for next session. One
more. Before we lose you, let's do that.
Yeah. So same time, in a week, we will talk really about the DAISY system, about the biological approach. We also will really go very deep in general, of course, in our product APF, but in general about coagulation, flocculation, impact of pH, alkalinity, all this stuff, how you have to mix it, how you have to dose it, that you're not overdosing it. And so really important also for crypto removal. We will talk in detail. I guess that's Sean's favorite, ACO, no FOS. So I hope we will do an interesting session for you, and we will